So today we will discuss about supports, types of supports, and what are the support reactions are there when a support is applied to a structure. So basically there are three types of supports which are used in structural analysis. The first one is your hinge support. First one is hinge, and the second one is roller, and the third one is fixed. They are the three supports. Hinge, it looks like this, and roller and fixed like this. In structural analysis, if a hinge support is there, then at that point the horizontal displacement as well as the vertical displacement are restricted. So, in supports, if the horizontal and vertical displacement are restricted, that means a horizontal and vertical reaction forces will be generated at that point, which is known as support reaction. So, in hinge, it is restricted in x-axis as well as in the y-axis. Therefore, we will get two reaction forces in hinge support. One is the vertical reaction and second one is the horizontal reaction. As well as in the case of roller, here the horizontal displacement is possible, but it cannot go in the y-axis. That means in roller support, vertical displacement is 0. So here we will get only the vertical reaction because it is not restrained, the movement is not restrained in the horizontal axis. Therefore, we will get one reaction which is our vertical reaction. But in fixed support, the displacement in x-axis as well as in the y-axis are restricted. So, we will get two reactions, VA and HA, as well as it is a special case where the movement is also restrained. Therefore, we will get another reaction which is known as our movement. So, in hinge support, our R is equals to 2. In roller, our R is equals to 1. And in fixed, R is equals to 3. Okay. So, in simple term, support reactions are the reactions which is generated by the support when the displacement is restrained. Okay, let's go to the next topic, which is our how to solve or calculate the reaction forces. Uh, to calculate the reaction forces, one equation is there which is known as equation of equilibrium. So, equation of equilibrium. Equation of equilibrium. In this equation, there are three theorems are there. The first one is the summation of all the forces acting on the horizontal direction or axis. Summation of all the forces acting on the horizontal axis is 0. It can be written as summation of Fx equals to 0. And the second one, it states that summation of all the forces acting on the vertical axis is 0. We can write it down like that, summation of Fy equals to 0. Summation of all the forces acting on the vertical axis is 0. It can be written as summation of Fy equals to 0. And the third one, is, first of all, we have to take all the horizontal forces and add them to a value of 0. After that, we have to take all the vertical forces to make it as 0. Then the third one is the most important, which is summation of movement at any point is equals to 0. Summation of movements at any point is 0. That is summation of movement at any point x, y, z or a, b, c is equals to 0. By considering these three equations, we can calculate the support reactions of any beam or structure or any member. Okay. Then types of loading. For different types of loading, we will be calculating the reaction forces. First of all, let's know about the types of loading. How many types of loading are there? Basically, there are 4 types of loading. The first one is your point load, and the second one is your uniformly distributed load, and the third one is your uniformly varying load. So, first one is your point load. Point load. We are having a beam of length L known as AB, and the point load is acting at the center. Then if a point load is acting at the center and it is spaced L by 2 from both the sides, it is known as point load. Then the second type of loading is your uniformly distributed load, which can be written as UDL. It is a beam AB in which a load is distributed throughout the length, having an intensity of W Newton per meter, and the length is L. UDL looks like this. Or in some books, you may be seen that UDL is also have drawn like this. This is a beam AB having length L. That means throughout the length, throughout the beam AB over the length of L, W Newton per meter forces is acting. That means if the length of the beam is L and W Newton per meter force is acting, then the total load will be how much? W multiplied by L, which is W into L. Okay. And the third one is the uniformly varying load. Suppose it is a beam AB in which at point A the load is 0 and towards the point B the load is increasing. That means uniformly the force is increasing when we will move from the left hand side to the right hand side. This is known as your uniformly varying load. Here we have to take the area of the triangle for calculation of load, which we will be discussing further. Okay, next.